Welcome to Retro Depot. I apologize for the garb. Just got off work, but I was talking to a couple guys on the Z80 DIY Facebook group, and one of them asked about what he needed to have in order to program an AVR. He's looking at possibly using an AVR as a kind of a bootloader for his Z80 project. In other words, he wants to be able to send the data to the AVR through serial, or USB if you will, and then take that data and program the RAM chip with that data and then reset the Z80. Pretty interesting concept. It's been done a couple times before in various different formats, but he was asking what tools he needed in order to be able to program those and kind of a process behind it. So this video is just geared towards programming a AVR. In this particular series, we're actually going to be looking at the AVR, the Atmel 18 Mega 16, and specifically the A, and it's this little board here. And what we're going to be using with it is actually going to be the USB ASP. It's just a little tiny PCB with a USB end on it and a little ribbon cable. Not much to it. I've built this board myself. Not much to it. It's got just some wires on the back, and it's got a USB connector here for power, but it actually uses RS-232 serial. I wanted a small little controller that I could take with me and kind of develop things with. Of course, I have a breakout for all the pins. So really kind of a neat design, but this thing here just plugs right into it just like that, and you're able to program. So nice to be able to put together your own little dev boards like this. I use them for a variety of different things, but we're going to go ahead and take a look at this real quick. It's pretty simple, and then at the end of it, I'll actually show you that this does in fact do what we program it to do. Alright, stay tuned. Okay, so this is the first thing that you need to find. You need to find the pinout for the particular chip that you're going to be using. I think that goes fairly with it, mostly without saying. But up here I have pulled up the AT Mega 1632, which is the type of chip that I'm going to be showing you how to program today. And the pins that you need to be concentrating on are the pins that are used for the serial programming interface. Now obviously we want power and ground. The two grounds are connected internally, so you can just use one or the other. It doesn't really matter. Obviously we are going to need reset, and then in addition to those three, you're going to want MOSI, MISO, and clock, which is master out serial in, master in serial out, or slave out rather, master out slave in, master in slave out, and then also the SPI clock, because these are essentially your SPI pins. Now once you have that, you're going to want to have some way of programming these. Now I'm, like I said, mostly using AVR Dude, and I use the AVR Dude S version 2.6 interface, and this is essentially just a Win32 GUI for the use of a otherwise command line only program. So that's one option. Another option that you can use is to program directly from the Arduino IDE. This one that I'm currently using is Arduino 1.8.5. But if you are going to use the Arduino with this, you're going to want to make sure that you actually have the proper core files. Now these are essentially the things that you need to have in order to be able to program. This one's in particular called the Mighty Core, and of course the address is right there. You can just plug that into your browser and you'll get to this page. And the thing that you're looking for is actually going to be down here. Let me see if I can find it. There we go. So you're going to want to find this and just copy it. And you'll want to go into your Arduino IDE, go to File, preferences, and then you can just plug that in right here. Or if you've got multiple things that you would like to pop up there, which I currently don't because I recently reinstalled Arduino, you just pop up this little window. You can plug in one here, you get to the end, and then you just hit enter. It'll drop you down to the next line, and you can plug in another library there. But we're not worried about that right now. We already have it brought up. So once you've got at least some type of tool ready to go, whether it be the Arduino IDE or let's say a Mini Pro, which what you would do with the Mini Pro is you'd actually come over here to MCU, Atmel, and then you'd scroll down until you saw the AT Mega series. And this particular one that I'm using is actually the AT Mega 16A. So I would click A, and then that brings me up with all my different options right here. So what we will do is we will plug in the Mini Pro, and we're going to just test to make sure that it works. And it does not have a chip in the socket. Everything works fine. Now I'll have to pull this AVR out of the board, so that'll take me just a second. But I'm going to go ahead and pull the file here, and I'm going to show you that it does in fact have code internal to it. So I've got my AVR plugged in at this time, and what I'm going to do is read from the chip. Now once I do this, it's going to read all of the program data here, but it will also get the data memo, or the flash if you will, and then it also grabs the fuses for purposes of configuration. So I'm going to go ahead and read this at this time, and of course you see down here it's got a low byte of E1, high byte of 99, and a lock byte of FF. And there's a couple other bytes that the Mini Pro doesn't actually look at, but we're just going to go ahead and read that data. And as we can see, our fuse bytes have changed. We got FF, DA, FF now. And you can see we've got our program data here. We don't have any memo data because I'm not using flash for anything, but it does change the configuration of the low and high fuse bytes, and of course the lock byte as well. So that worked. So what we can do is we can actually we can save this data. So let's go to the desktop, and we're just going to save this as a hexadecimal file, or a hex file rather, Intel hex if you will, iHex, and we're going to name it, let's just use ATM16. So that should at least let us know what we're trying to save it as. Okay, so now that we've done that, if we wanted to program this data, obviously we could clear all the buffer, and of course that clears out the fuse bytes as well. Now if we plug this in, let me see, I think that was the right one. Yeah, that's the right one. So if we plug that in there, now it has all of our data, but if you've noticed, it did not change the fuse bytes. So that's pretty important. You definitely want to make sure that you probably want to read the chip, or at least know what fuses you have. That way you can go into the configuration and set these bits accordingly. Now having said that, I could program it like this and it would write these bytes here. I don't want to do that, so we're not going to do that. But if you wanted to, obviously you would just hit program, and then you could actually, if you wanted to, you could actually turn the fuse bits off, and that's probably what I would do if I was going to program this at this time. But I'm not so much worried about it with the Mini Pro. I'm just showing you the Mini Pro in case you have it. It's one option for being able to do that. Now as far as the Arduino, there's a couple different ways that we can do this. I'm just going to unplug that for a moment, and let me see if I can plug in my USB ASP. Okay, so now that's plugged in. So there's a couple of different options that you have as far as using a dedicated ISP programmer, and of course ISP means in-circuit programmer, in case you're not familiar with that. But I've got a sketch here, and this is the blink sketch from the Arduino. It's the same thing that everybody knows. And I've changed this so that instead of it having the LED in, we're just going to use D0. And the reason for D0 is because on this particular board that I have, I've used D0. Now, as far as an LED, that is. Now, so we have this. Actually, I'll say that. Let me double check to make sure that is in fact. Yeah, that's D0. Okay. So now that we've done this, all we have to do is verify it, which it's going to do a short compile, and it's going to make sure that everything was good. So it doesn't know what D0 is. Maybe that's because I forgot that in the Arduino IDE you don't need to put D. So let's try it now. Well, one more. There we go. Is it going to work? Okay, it did. Now, the next step is we have to set this up to make sure that we're going to be programming the right AVR. And the first thing that we want to do is obviously, well, it did compile, so just a moment. So now that it's compiled, yeah, so we want to make sure it is ATmega16, and of course you want to make sure you select the tiny core. You can choose your brownout. 2.7 is fine. Pinout is standard. The clock, I'm using a external 16 megahertz ceramic oscillator with this particular one. It's a 3-pin ceramic oscillator, so it is at 16 megahertz. We'll keep that, but if you needed to go internal, you can just select internal, and of course it will program all of that for you. We don't really care about the LTO, COM port, don't really care about that, but we do want to make sure that we're going to be using the USB ASP. So let's see if we can find it here. There it is, right there. So that's the one that we're going to be using. Now we've got all of this set up, and I'm going to go ahead and plug this in, and if everything goes right, we should be able to program now. So what we're going to do is we're going to just click upload. And it's uploading. Or it says it is. It may not be. This is a little bit older software. I haven't updated the software in a little while. So it's possible that it might not be working. And I think that is probably the case. But that's good. That gives us the ability to try this again. So I'm going to stop the video and I'm going to get this booted back up. Okay, we're back. So this is what I'm going to do. I'm actually going to verify it, and of course it's the same sketch that I used before. I've changed the zeros from the built-in LEDs. So it's done compiling, and now I actually want to go here to Sketch and export compiled binary. Now it's going to export this binary, and it's done. Now where did it save it to? Well, that depends. The easy way to find it is to actually go to your documents where you have your Arduino folder, and then whatever you saved it under. So I've got the Arduino file here, but it gave me two options here. Both of them are iHex files. One of them is the Blink 16 INO with bootloader at 16 megahertz, and the other one is the Blink 16 INO ATmega16 without the bootloader. So in this particular case, I don't need a bootloader, so I'm just going to make sure I select this file here. Now, If you want to go back, I don't know why my software locked up. Like I said, I'm using an older version of Arduino here, and it may not be quite compatible with the version of AVR Dude that I have on this. I don't really use the Arduino programming environment too often. When I do write AVR code, I tend to like to write in AVR Studio, but if I need to do some quick stuff with C, this is a pretty good environment. But if I wanted to upload with the programmer again, obviously make sure you have that selected. You'd go to Sketch, and then, or I say that, you actually want to go to, let me see here. Oh, to Sketch and Upload via Programmer. So we're going to actually try this one more time to see if we can get it to work. So we're going to upload using Programmer, and it's compiling the sketch at this time. Yep, didn't see it. It failed, which that's okay. That's okay. We're not worried about that so much because we have, haha, AVR Dude, or AVR Dude S. So you want to make sure that you select your file here. In this particular case, we're going to be using the USB ASP as before. It is under USB, and we can set our bit clock to however fast we'd like to. If you've never programmed one of the boards or one of the AVRs before, if it's a brand new one, I suggest dropping down as slow as possible, maybe around 16 kilohertz, because that's going to be slow enough that it will still be able to detect the AVR and do everything that it needs to do. But this one's already been programmed before, so I'm just going to set the bit clock to 1.5 megahertz, and that'll be good. Now, obviously, you need to select which micro it is, but if you don't know which exact micro it is, you can just click Detect. And as you can see, I've already detected it once, but if we detect it again, there you go. It detected it one more time. So now, how do we actually write our program? Well, that's pretty easy. What we can do is we can go here to this. We can go to Arduino. We can go to the Blink 16 and then select this file here. And now it's got which one it needs, but we still need to be able to read our fuses. So let's read our fuses real quick. So FFDA, that's correct. And then our lockout bit is 3F. That's a little bit different. It should be FF. But okay, we're not worried about it because we're not going to be writing. You would use these two to write those. We're not even worried about that. So what we're going to do is we're just simply going to write the flash, and you don't have to do everything here. You can just simply click Program, but if you just want to write the flash, this would be the way to go. So it's programmed and it's done. It's that simple. And I'm sitting here looking at my AVR board, and it is in fact blinking. So having said that, it worked. All I had to do was export via the compiled binary at Control-Alt-S, and then bring up AVR Dude, set everything up, and it's there. It's really that simple. So I hope you found that beneficial. If you have any questions, feel free to comment below or even shoot me an email. Hit me up on Facebook or Messenger. You know, most of the people that are going to be watching this probably have my contact information. But if you're new and you don't know, you know, where to find me, my website is retrodepot.net. You can use the contact form there to send me an email, and I will respond. Alternatively, you can comment on here, and I'd be happy to answer any questions that you may have. And then, obviously, if you're on the Z80 DIY Facebook group, go hit me up over there. I'd be more than happy to help you out. Alright, that's it for today, guys. So that was it. We've programmed the ATmega 16A just to prove that it does work. I've got the board here, and I've got a USB cable. If I plug it in, you can see LED is blinking. So hey, it works great. No problems with the programmer whatsoever. A few problems with the Arduino environment. For some reason it didn't want to upload. I think it may have actually been my fault though. I think I actually tried to program it through the normal built-in USB port, and of course that's not going to work. I think I should have tried programming it via the programmer, but I'm not going to go back and reshoot that portion of the video. This is just for demonstration purposes. So if you have any questions, feel free to drop comments below. Outside of that, if you're not a subscriber, feel free to subscribe. I'm always looking for new viewers and people that can comment and participate in the channel. Also, check out the website, retrodepot.net. And if you're interested in Z80 stuff, why not hit up the DIY Z80 computer Facebook group. I'll leave a link below. Pretty neat little group. If you're into that kind of stuff, it might be a place for you to go to get some pointers. Alright, so thanks for watching, and we'll see you next time.